So if you have any question, okay, again, you can type in the chat window, okay? Yeah. So first, let's finish this reaction, and then I will talk about kind of the final exam, okay? All right, okay, so yeah, for the Aldol, yeah, the reaction, okay, so yeah, keep in mind, okay, so even in the question, give only one molecule, okay, once you identify this kind of Aldol reaction, okay, you need first kind of quickly draw two molecules, same molecule, just next to each other, okay. Okay, that's the first thing to do, okay. So yeah, the Aldol reaction normally happens between kind of two aldehyde or two ketone. Aldehyde is kind of much easier, okay. And then NaOH as kind of the base, okay. And then following kind of find the alpha carbon on one molecule and then carbonyl carbon on another molecule, okay. That's alpha carbon and then another molecule contribute kind of the carbonyl carbon, okay. So that you need to build bond between these two guys, okay. And then meanwhile, okay, so yeah, that's something like this, okay. So you open the carbonyl carbon, okay. So yeah, if you cannot draw kind of pretty one, okay. So yeah, you can draw ugly one, okay. That's fine, okay. So something like this, okay. So yeah. All right, so that's the product, okay. But yeah, if you want to draw a little bit pretty one, okay. So yeah, just here okay, that's a similar thing, okay. Yeah. All right. Probably not. Smart work don't accept it. But yes, I try to draw the kind of ugly one. So yeah, I draw the bond pretty long. Okay, so that's probably still accepted. Okay, so yeah, but yeah, you cannot draw the curved bond. Okay, so yeah, that's no such choice. Okay, all right. Okay, and then for the once you get to other product, okay, so yeah, like I mentioned in the class before, okay, so last time, okay, so yeah, if you see kind of heat line, that means kind of I want you show me kind of the condensation product. Okay. Condensation product pretty easy, okay. So you generate kind of the CC bond between alpha carbon, carbonyl carbon, okay, and then OH is gone, okay. All right, so that's it, okay. So there's only one bond between alpha. Yeah, so Aldol product, okay, only a single bond, okay, one bond between alpha carbon and the carbonyl carbon, okay. But here the Aldol condensation product, okay. So condensation product, okay, you generate the CC bond, okay. So that's here the keep in mind their difference, okay. So theoretically speaking, kind of for the Aldol product actually kind of no stable, okay. So easy go back to your starting material, okay, go back to the force, okay. But once you generate kind of the Aldol condensation product, okay, so that's your push reaction to the right, okay, so that's here the irreversible, okay. So yeah, normally speaking, kind of people generate always kind of the Aldol condensation product, okay. So yeah. So like the lab, we'll do this week, okay. All right, okay. So yeah, now I'll talk about kind of the final exam, okay. So yeah, on Monday, okay, so I received notice from department, okay, so yeah, inform me kind of the final exam has been done by November 24th, okay, so the end of this semester, okay. Originally I plan to, and that's the Tuesday, okay, so yeah, originally I plan to it kind of on in the weekend of Thanksgiving week, okay, but has been done before Thanksgiving, okay. So in this case, we will have no kind of quiz 7, okay, because there's no time for quiz 7, okay. We only have 6 quiz, okay, and but you are still allowed to drop one the quiz with lowest grade, okay. So yeah, only 6 quiz, okay. Quiz 5 this week cover the chapter 19, okay, and then quiz 6, okay, cover chapter 20, okay. So that's your current chapter, okay. And then we will have kind of exam 3, okay. Exam 3 probably cover chapter 19, 20, and also probably chapter 22, okay. So yeah, paracyclic reactions, okay. And then we have some time, okay, finish probably the last chapter 20, ones can radical reactions, okay. And then we can have the final exam, okay. All right, so here's the pool question for you guys, okay. And for the final exam, okay, so the last class for this year, the organic chemistry one will be on Friday, okay, so that's December 20th, okay, and then we can have once we done the last class, okay, we can have kind of final exam, okay. So 4 days you can you can choose, okay, to take the final exam, okay. So that's Saturday, Sunday, and Monday, and also a Tuesday. Okay, the latest day is kind of a Tuesday. Okay, so if you're thinking too many exam on Tuesday, okay, you can do it early. Okay, so if you think kind of you want more time to study, you can choose the Tuesday. Okay. The final exam will be 2-hour exam. Okay, 2-hour exam still based on smart work. Okay, and then it's accumulated. Okay, cover all the chapter we learned in organic chemistry 2. Okay, all right. And just the pick up your date. Okay, so yeah.
What time will it be?
That will be probably pretty long time. Okay, so because 2 hours probably I will open from 4 until midnight. Okay, from 4 o'clock. Okay, yeah. If you guys like, maybe I can even open from 2 o'clock. Okay, so yeah, in the afternoon. Okay, yeah. All right, so yeah, please make a choice. Okay, pick which day do you want to take the final exam. Okay. Saturday, Sunday, Monday, or Tuesday, okay, and then give you 3 seconds, okay. 3, 2, 1. All right. Okay, so okay, so looks like most students like actually kind of more than half the students like the Tuesday, okay. So in this case, we'll have kind of the final exam on Tuesday, okay. And if you have a conflict schedule, okay, so for example, you have to travel back to home, okay, on Tuesday, okay, or some other kind of you have to work on that day, okay. So please let me know, okay, so I can arrange another time for you, kind of take the final exam, okay. All right, thank you. All right, okay, so we'll continue at chapter 20, okay. So yeah, like I said, okay, so most time kind of reaction push to the end give kind of that's what I actually called kind of alpha beta unsaturated ketone, okay. So the reason for that kind of this conjugation stabilized kind of final product, okay, and then give kind of more stable product, okay. And so that's showed also here, okay, dehydration shifts equilibrium to the product directions, okay. And here showed kind of 2 examples, okay. The first one kind of butanol, okay, so aldehyde, okay, and then give kind of the 1 molecule, okay. Another one kind of even much longer carbon chain, okay, so give also kind of the dehydration product, okay. And you can see kind of the yield kind of 97 pretty good, okay, 79 is also pretty the decent yield, okay. And for the Aldol reactions, okay, so Aldol reaction kind of why it's called Aldol, okay, so because normally this reaction happen to kind of aldehyde, okay. But indeed can also happen to kind of ketone, okay. So but aldehyde is much more preferred than ketone, okay. Much more preferred, okay. Reason for that kind of pretty easy to understand, okay. So the steric hindrance, okay. So for example, that's 2 ketones, okay. So that's pretty the last open side, okay, for the nucleophile attack, okay. So the ketone is not easy, okay. But indeed can happen, okay. So but aldehyde kind of dominate, okay. So no alkylation for aldehyde. I'll explain it later, okay. All right, so so this is kind of another carbon-carbon bond formation reactions, okay. So for to synthesis on the other complex molecule, okay. And because the other other reaction statement can be the very huge one, okay. So in this case, you can build kind of very kind of the big molecule, okay. So like this one, okay. All right, and then to do the retrosynthesis, okay, so if I give kind of the one starting material, okay, so that's right, okay. So Aldol reaction only ketone aldehyde, okay, only ketone aldehyde, no other molecule, okay, no other molecule. Other molecule will have other reactions, okay, we'll talk about later, okay, aldehyde ketone, okay. All right, and so in the exam quiz, okay, so if you give you kind of the target molecule, okay, after kind of use Aldol reaction to make it, okay. So the key thing kind of you quickly identify what's original kind of alpha carbon and also carbonyl carbon, okay. Right, for example, yeah, that's here, okay. So this is kind of targeting molecule, very big molecule, okay. And then yeah, the casing, okay. So yeah, you need to find the alcohol, okay. So OH group, okay. So that's original kind of carbonyl group, okay. And then the carbon attached to it, okay. So that's here the actually original kind of carbonyl carbons, okay. So that's here the okay. And then the carbon between the alcohol part and also the carbonyl part, okay. So that's here the original kind of the alpha carbon, okay. So in the middle, okay, with these two carbons, okay. So that's alpha carbon. Once you identify it, okay, so the alpha carbon, original kind of alpha carbon, and also the carbonyl carbon, okay. So pretty easy, okay. So the bond formations here, okay, so break up this molecule into two parts, okay. So that's you kind of original molecule, okay. So yeah, we'll do some kind of practice in the discussion tomorrow. Yeah, in the discussion tomorrow, okay. So yeah, we'll some kind of still practice on chapter 19. Help you guys prepare kind of quiz on Friday, okay. And we'll also kind of practice some kind of chapter 20 kind of the content, okay, because the chapter 20 kind of relatively hard one, okay. Yeah, that's how do you kind of use the Aldol reaction make this molecule, okay. All right, and then there's a very interesting topic about kind of mixed Aldol condensation, okay, also called kind of the cross Aldol reactions, okay. So yeah, if you have kind of two different kind of the aldehyde or ketone, okay, so in one pot, okay, you try to do the Aldol reactions, okay. So normally speaking, you can generate kind of all the possible product, okay. So yeah, reason for that case, so that's here showed one example, okay. So we have kind of the acetaldehyde, okay, and also this one kind of propanol, okay. And so each of the molecule has kind of their own alpha carbon and those carbonyl carbon, okay. So in this case, we can have two kinds of alpha carbon, two kinds of carbonyl carbon, okay. So yeah, you can have all the possibility, okay, all kind of cross kind of okay, product, okay. So yeah, this aldehyde can react with cell, okay. So and then this one, yeah, alpha carbon can attack carbonyl carbon here, okay. This second kind of aldehyde can react with therapy, and then its alpha carbon can also attack kind of the first aldehyde, okay. So eventually you generate kind of all the kind of full possible product, okay. So that's actually kind of pretty useless, okay, for the synthesis, okay, organic synthesis, okay, because they are generate kind of full product, okay. So yeah, all of them have kind of same kind of similar kind of the property, hard kind of the separate all these four, okay. And but pretty useful kind of for the exam quiz, okay. So yeah, we'll practice some kind of the mixed Aldol condensation, okay. So in the discussion tomorrow, okay. So yeah, that's very good way to help you guys kind of learn Aldol reactions, okay. All right, so for the reality, okay, so yeah, if you have kind of the two different aldehyde ketone, okay, try to kind of mix the Aldol condensation, okay, you always want to kind of get only one single compound, okay, single product, okay. So how do we control the product, okay? So one way is kind of you use kind of aldehyde without kind of alpha carbon, alpha hydrogens, okay. So that's actually kind of related to the experiment we will do this week, okay. So this week here the unknown, okay. So unknown is kind of the benzyl aldehyde, okay. All based on benzyl aldehyde, okay. So you have some kind of other substitutes on the benzene, okay. So that's kind of unknown, okay. So for the benzyl aldehyde, okay, you can see kind of this is alpha carbon, okay, but there's no alpha hydrogen on it, okay. So in this case, yeah, this one cannot use as a nucleophile, okay, can only be attacked by others, okay. So yeah, this molecule only contribute kind of the carbonyl carbon, okay. And so yeah, another is kind of the ketone nitride as a nucleophile, okay. So ketone nitride, okay, so yeah, normally speaking, kind of can contribute kind of the alpha carbons, okay. It here the carbonyl carbon not easily attacked, okay. So because kind of bar inside of the molecule, okay. And that's also for this week lab, okay. So this week lab, okay, so yeah, we have another region called kind of acetophenol, okay. Yeah, so that's acetophenol, okay. So that's actually kind of also 1K. Yeah, kind of ketone, okay. So it will contribute kind of alpha carbon, okay. So that here generate kind of the major product, okay. Just here this one attack here, okay. So generate kind of Aldol product, okay. And so another way to do it kind of add the region kind of not in one pot, okay. Do it kind of in order, okay. So normally speaking, kind of you add just dropwise add kind of ketone into the aldehyde solution, okay. Because you have large amount kind of aldehyde, once you ketone add in, okay, and then ketone quickly kind of react with the aldehyde, large amount of aldehyde won't react with itself. Okay, so that's another way to do it. Okay, so all right. Okay, so and some students kind of still don't know how to draw the product. Okay, so that's pretty easy. Okay, so this one can be kind of the alpha carbon. So this one can be kind of the carbonyl carbon. Okay, so once reaction is done. Okay, so because we do kind of Aldol condensation. Okay, eventually kind of OH group is gone. Okay, and then become kind of CC double bond. Okay, and then you get kind of something like this. Okay. So that's the original kind of alpha carbon, original kind of the carbonyl carbon. Okay, right. So that's and then whatever attach on kind of the benzene ring or the kind of unknown, you still got here. Okay, so that's how to draw it. Okay. Yep. All right. So here are some kind of other examples. Okay, the first one kind of still carbonyl carbons. Okay, this kind of benzoaldehyde. Okay, only contribute carbonyl carbon. Okay, another one kind of another aldehyde as kind of contribute kind of the alpha carbon. Okay, so that's your general kind of Aldol condensation product. Okay, pretty decently yield. Okay, 80%. Okay. Right, and so next example kind of still use here the benzoaldehyde as kind of the electron file can call them kind of could be the carbonyl carbon. Okay, and then we use acetone as a nuclear file. Okay, so acetone has kind of two carbonyl carbons. Okay, the two kind of alpha carbons. Okay, so in this case if you have excess of benzoaldehyde, okay, and then you can add that kind of two Aldol reactions. Okay, two Aldol reactions, and then kind of this some kind of the conjugated ketone. Okay, and the last one's kind of nitrate compound as contribute the alpha carbon. Okay, so nitrate compound pretty cool. It's kind of there's no carbonyl carbon. Okay, so this the nitrate carbon is cannot attack by nucleophile. Okay, so and very weak kind of electron file. Okay, so in this case the nitrate only contribute kind of alpha carbon and reacts with kind of again that's here benzoaldehyde. Okay, so that's you can kind of find the product. Okay. So that's someone asked kind of the happen between kind of aldehyde ketone. Okay, so that's actually kind of last example a little bit kind of exception. Okay, so nitrate compound can be used as kind of the nucleophile for the Aldol condensation. Okay, but not so common. Okay, but not so common. Okay, so and also nitroarchene. Okay, nitroarchene also can go on to the Aldol reactions. Okay, so nitroarchene is kind of because just give you one simple example. Okay, right. So we use kind of the nitromethane as example. Okay, so the NH2 kind of strong electron withdrawing group. Okay, so and then can stabilize kind of the CH2. Okay, so this is your alpha carbon. Okay, as nucleophile open the CO double bond. Okay, so and so let's do kind of the one product. But those the pretty last common. Okay, for example, we still use this one react with kind of the benzoaldehyde. Okay, so once reaction is done. Okay. OH heat. Okay. So that's final product. Okay. So that's the methyl group. Okay, so goes here. Okay, and then carbonyl group. Okay, so that's the goes to this carbon. Okay. But those kind of last common. Okay, so normally speaking, kind of in exam quiz. Okay, so I only test you guys kind of aldehyde ketone for the Aldol reaction. Okay. Right. Okay. So that's we done kind of Aldol the reactions. Okay. So next we move kind of back to other reactions. Okay. Right. So the first reaction we're going to learn is kind of called halogenation. Okay. Or for alpha carbon, I just put kind of halogenation. Okay. So this one kind of relative new reactions. Okay. So and so can happen either on the kind of acid condition or kind of basic conditions. Okay, what happened kind of the normally speaking now still aldehyde ketone. Okay, so react with kind of hydrogen. Okay, so like the chlorine, iodine, and all the bromine. Okay, fluorine I'm not sure. Okay, I didn't see any fluorine. Okay, and then you kind of it looks like here the replace one alpha hydrogen. Okay, with kind of halogens. Okay. but it really depends kind of what's reaction conditions, okay? So if you're under acid condition, okay, so only replace one alpha hydrogens, okay? But on the basic conditions, okay, you can replace as many up to kind of 3 hydrogens, okay? Yeah. So that's here quite the interesting thing, okay? So I will write down here, okay? That's it, okay? All right, so probably still, right, still use color talk. Yeah. So if it's under acid conditions, okay, and then no matter how many kind of hydrogen, okay, on the alpha carbon, okay, only one hydrogen is replaced by kind of the halogen. And then another byproduct kind of the HX, okay. Yeah, only one, okay. And so if it's kind of under basic conditions, okay, and then if you have excess of the halogens, okay, so all the 3 hydrogen can be replaced by kind of the halogen. Yeah, excess, okay. Right. And then so basic condition, okay, so normally we use kind of sodium hydroxide as base, okay. All right. So all 3 hydrogen replaced kind of by halogen, okay. All right. And so for this reaction, okay, actually kind of note down here, okay, yet, okay. So if you had kind of little bit kind of the more base, okay, and also if you like, you can also do kind of a little bit acid workup, okay. So so once the reaction is done, okay, so actually reactive generate kind of carboxylic acid, okay. And plus we call kind of the haloform. Okay, haloform, okay, HCX3, okay. So like chloroform kind of Cl3, okay, H, okay. So the bromine form, okay, haloform, okay. All right, so that's one thing, okay. So another thing kind of keep in mind, okay. So these two actually kind of go through kind of different mechanism, okay. The reason for that, okay. So acid conditions, okay. So actually kind of go through kind of enol, okay, as intermediate, enol as kind of the nucleophile, okay. As a nucleophile, okay. And for the basic condition, actually kind of the enolate as a nucleophile, okay. So that's why they have kind of somehow a little bit different product, okay. And then another thing you can keep in mind kind of eventually, okay, so that's actually kind of no matter acid or the basic condition, okay. So if you have alpha carbon, okay, alpha carbon is kind of the chiral carbon, okay. So you have kind of 4 different attachments, like the top example, okay. After reactions, okay, so eventually generate kind of racemic mixture, okay, so racemized, okay. So why that, okay? Because enolate kind of enolate kind of intermediate, okay. Yeah, hydrogen can be carried kind of acid base condition, so lose their chemistry because intermediate, okay. So here's kind of show you kind of mechanism, okay. So for the halogenation reaction mechanism are not required, okay, but just kind of quickly go through it with you, okay. So explain why these two have different product, why kind of racemization, okay, something like this, okay. All right. So first kind of the acid conditions, okay. So for acid conditions, okay, so like most kind of carbonyl compound react under acid conditions, okay. The first step always kind of carbonyl oxygen pick up hydrogen, make this the carbonyl more reactive kind of we call the activated carbonyl, okay. Right, and then some weak base come in, pick up here the alpha hydrogens, okay. You generate kind of enol, okay. So that's enol, okay. So this one kind of probably the only reaction in this chapter we have kind of enol as a nucleophile, okay. Right, and then this the electron shift back, okay. So open the C bond, okay, pick up 1 hydrogen, okay. and eventually kind of another kind of hydrogen ion pick up this hydrogen on kind of carbonyl group, okay, give you kind of final product, okay. All right, so once why this reaction got kind of racemized, okay, reason for that kind of you turn kind of enol intermediate, okay, so you kind of CC that bond, okay. So in this case when you do kind of the next step, okay, so that's addition of the hydrogens, okay. So this hydrogen can go from top of the theta bond or kind of from bottom of theta bond, okay. So that's just kind of totally racemized, okay. So similar like the mechanism 1, okay, we learned in the chapter 11, okay. So arcing addition, okay. So kind of give you kind of just a single the enantiomer or single kind of stereoisomers, okay. All right, second kind of why the reaction stop at kind of only single the hydrogen be added, okay. Reason for that, okay, this guy, okay, enol, okay. So once you put one hydrogen on it, okay, so put on hydrogen on it, okay. So this hydrogen kind of hydrogen normally kind of electron rejoin, okay. So maybe. All right. So acid conditions, okay, so we generate here the enol intermediate, okay. So once you put one hydrogen on it, okay, so the hydrogen kind of electron rejoin, okay, so pull electron, okay. Something like this, okay. And then make here this the enol not easily form anymore, okay, not easily formed, okay. So in other words, okay, so single bond, okay. The starting material should be like this, okay. So there's maybe hydrogen, okay. Starting material should be like this, okay, and then the oxygen pick up the hydrogen, okay. But because this kind of inductive effect, okay. Right. So pull electron away, okay. So make this oxygen not easily pick up the hydrogen, okay. So that means kind of this pathway kind of stopped, okay. And then you cannot generate kind of enol intermediate, okay, and then that kind of the not easily kind of forward, kind of move forward for these reactions, okay. So the reason for that kind of the electron rejoin by the kind of hydrogens, okay. So no enol kind of intermediate formed, okay. That's a double bond on the carbon. So on this one has kind of the double bond on CC double bond, okay, and this one has CO double bond, CC single bond, CC single bond, okay. So CC single bond, okay. All right, okay. So that's about kind of the acid condition, okay. So now we move to kind of basic conditions, okay. The basic condition, why is kind of we'll first go through kind of quickly, okay. So so for basic condition, okay, pretty much kind of just directly kind of strong base pick up kind of the alpha hydrogens, okay, and then you generate kind of the enolate, okay, right, enolate, okay. So for the basic, okay. All right, so that's enolate, okay. Enolate you can draw kind of two forms, okay. So doesn't matter, okay. These two kind of the resonance structures, okay. Right. So these two are both can call enolate, okay. And then this the enolate, okay, directly at the nucleophile, okay, pick up one hydrogens, okay. So that's showed pick up kind of halogens, okay. That's showed here, okay. All right. So that's the enolate kind of and then pick up kind of halogens, okay, and give you kind of final product, okay. So why can have kind of you cannot stop at kind of only add one the halogens, okay, you continue add the second one, okay. That's kind of the intermediate, okay. So now I put here the for example, okay. So after the first halogenation, okay, you put the halogen on, okay. All right, and then this halogen kind of still electron rejoin, okay, have to stabilize kind of the enolate, okay. So Enolate has kind of lone pair electrons, negative charge, okay. So that's the pull it away, okay. So that's help kind of stabilize, okay. And then make this Enolate kind of more kind of reactive kind of more stable, okay. And then can carry kind of reactions, okay. So that's showed here, okay. Adding kind of electron to make the remaining hydrogen kind of more acidic kind of it's conjugate kind of more stable, okay. So the hydrogen won't go back, okay. And then so the hydrogen, second hydrogen quickly add on, okay. So eventually kind of you cannot stop at kind of single hydrogenation, okay. You get kind of maybe 2, 3, okay. So okay. So for you guys, okay. So if you still don't understand what's going on, what's mechanism, actually kind of mechanism not required for this question, okay. So for you guys, just remember, okay. So for these reactions, okay. Depends what reaction condition, okay. Acid condition, okay, so you generally kind of the mono substitute kind of the halogenated kind of product, okay. Basic condition is can get kind of as much as possible kind of the final product, okay. Replace as much as possible kind of the kind of R hydrogens, okay. All right, okay. So now kind of the 2 examples, okay. Okay. All right, the first one is kind of the acid conditions, okay. So in this case although there are kind of totally 1, 2, 3, 4, okay. So the R hydrogens, okay, but actually only one is kind of replaced, okay. Okay, so that's product, okay. So I guess because kind of rejoin group and also conjugated system, okay. So this once you add one hydrogen, okay, so make another R hydrogen kind of R hydrogen on not set kind of not so acidic, okay. So that's why I can only put one end on, okay. Right, and then another one kind of on the basic condition, okay. Right, so that's your methyl group, okay. We have bromine, okay, and then sodium hydroxide, okay. Yeah, excess, okay. Right, so once this reaction is done, okay, so if didn't do any work up, okay, so what's the final production kind of the carboxylate, okay, and plus kind of the we call kind of bromoform, okay. Okay, so pretty much you're totally clear of kind of this the methyl group, okay. So the reason for that kind of the first step, okay. So we generate kind of this structure, okay. So that's this one kind of the CX3 kind of very strong, kind of the like region group, okay. Polarized kind of response, okay. Easy to break it up, okay. Easy break up, okay. And then normally speaking, kind of quickly OH coming, okay, replace kind of the CX3, okay. So that's actually also kind of very good lead group, okay. So and then so for the basic reactions, okay. So for reality, okay. So the product stop at here, okay. So push one more step, okay. So that's the something just kind of keep in mind, okay. So so normally speaking, kind of the exam quiz, I can tell you kind of eventually you need to draw kind of carboxylic kind of product or carboxylic product, okay, and with kind of the haloform, okay. Right, and then actually where does the third BR come from, okay? The third BR, okay. So this one kind of excess, okay. So BR2, okay. So you kind of has a lot, okay. So that's why kind of the eventually, actually even you have kind of the one BR, okay, 2, okay, one BR2, okay. So 1-to-1 equivalent, okay. So eventually you also generate kind of the large amount of capacity, okay, with kind of a lot of starting material no react, okay, because you make the starting more reactive after you add one BR, and then if you add second BR, even more reactive, okay, and eventually you kind of final product, okay. So let's work out the origin. Yeah, that's right. Okay, so if the work up, okay, so work up, okay, so yeah, that's you just give kind of carboxylic acid, okay. Yeah, so work up like this, okay, so it doesn't matter, okay, so doesn't matter you work up or not, okay, so you just push to the end, okay. Okay, so that's the yeah, haloform reactions, okay, so yeah, now yeah, haloform reaction, okay. So yeah, if you use iodine, okay, as kind of the halogenation reaction reagent, okay, and then after reactions, okay, so we actually kind of you kind of we call the Aldol form, okay, this one, okay, and then this one actually kind of yellow kind of precipitation, okay, so yeah, cannot dissolve kind of in the organic solvent, okay, so that's actually kind of pretty good indication kind of you have kind of methyl ketone, okay, so yeah, so that's the were kind of the old way to test kind of methyl ketone, okay, so we call it kind of Aldol form test, okay. So like we learned kind of the biostain test, okay, for the kind of the halogens, okay. Aldol form test, okay, so it's for kind of the methyl ketone, okay. Actually also can be used to test kind of the acetaldehyde, okay. So acetaldehyde has kind of this structure, okay. Methyl ketone, okay, so methyl ketone has like some R group, okay. So because all of them can generate kind of the Aldol form product, okay. So it's just pretty much you click for kind of this methyl group, okay, and then give kind of the Aldol form, okay. And if you take second look at the actual kind of for the Aldol form test, okay, all these compound have the same kind of we call kind of acetal group, okay, acetal, okay. Yeah. And so yeah, this means kind of if you want to do the kind of Aldol form contest, okay, you have to measure kind of the 3 hydrogen on the alpha carbons, okay, so that's why it has going to be methyl group, okay. And so yeah, be used kind of for the methyl ketone and also Aldol, acetaldehyde, okay, so yeah, yellow precipitation, okay. And this reaction pretty easy, okay, so yeah, you just kind of add the sodium hydroxide, okay, plus kind of iodine, okay. Yeah, this kind of two region into your system, okay, and then you just kind of if you see kind of yellow precipitation, that means kind of you have this kind of acetal group, okay, in your molecule, okay, so yeah, so that's when I was kind of undergraduate student, I did some kind of this test, okay, but nowadays kind of the people just use any market to figure out what's unknown whatever, okay. All right. Okay, so that's the first reactions, okay, so yeah. Halogenation reactions, okay, so for halogenation reactions, keep in mind, okay, so if it's under acid conditions, okay, so you only put here the replace one R hydrogen with kind of halogens, okay. Basic conditions, okay, so you push two kind of carboxylic acid, okay, that's or carboxylate, okay, so either one, so depending on whether you do kind of acid work up or not, okay. So otherwise, the not too hard, okay, you don't need memorize kind of mechanism, okay, and yeah, just keep in mind, okay, so Aldol form test, okay. So NaOH, iodine, K, test kind of the methyl ketone or kind of acetaldehyde, okay. All right, okay. So now we move to kind of second reaction, okay. Second reaction kind of little bit hassle, okay, called kind of alkylation, okay. So alkylation actually kind of similar reaction kind of we learned before, okay. So the SN2 reactions, okay. But this time, okay, so the alpha carbon do the SN2 reaction. Okay, so as long as you keep this one in mind, okay, so that will be kind of much easier for the reaction here, okay. And so for the alkylation reactions, okay, only happen to kind of for the ketone, ester, and those the nitrite compound, okay. All Right, so general reaction actually kind of pretty easy. Okay, so yeah, just quickly still show you guys. Okay, right. So we have this the carbonyl compound. Okay, this is the R carbon. Okay, and then you use kind of strong base. Okay. And react with kind of substrate case, substrate kind of any substrate will then be full kind of with good link group case. So yeah, all right, okay, all right, and then pretty much once reaction is done, okay, so this alpha carbon as a nucleophile repeats kind of leaving group case. So pretty much it's kind of SN2 reaction, okay, pretty easy. Yeah. So HR, if you like draw it, okay, it's fine. Okay, if you don't like draw it, it doesn't matter, okay. All right, and here's kind of showed you kind of a little bit of mechanism going on. Okay, so pretty easy. Okay, so first case strong base pick up kind of the alpha hydrogens. Okay, and then kind of the enolate. Okay, so this time case so enolate as intermediate, and then enolate kind of the alpha carbon as a nucleophile to SN2 reaction. You put kind of alkyl group on. Okay, so that's why I called kind of alkylation. Okay. And for this reaction, okay, because of the ketone ester and also the nitrate kind of R carbon has kind of the relative the high pKa. Okay. So that means here that you have to use kind of relative strong base here for these reactions. Okay. So that's the common base we use here kind of the similar like we learned last time. Okay. Sodium hydride, okay, sodium amide, and also LDA. Okay. So the lithium diisopropyl amide. Okay. So that's here enough to kind of depronate kind of the alpha hydrogens. Okay, right. Here a question, okay, for you guys. Okay, so why the aldehyde cannot do kind of alkylation? Okay. Right. Anyone know what's the reason? Okay. So aldehyde also have kind of kind of alpha hydrogens. Okay, why it cannot do this reaction? Okay. Right. Okay. Yeah, that's some kind of the good answer. Okay. Yeah. So actually kind of the main reason actually we just learned it, okay, because if you have very strong kind of the base here, okay, so you already have a kind of Aldol reaction. Okay, it will react with itself first, okay. Okay, so it's one kind of go ahead kind of pick up kind of the alkyl halide, okay, to SN2, okay, it's will kind of it's react with itself, okay, so do kind of the some Aldol reaction, okay, because I already had like Aldol reaction a lot, okay, so so that's the main reason for that, okay, yeah. So in this case, keep in mind, okay, so the Aldol reaction like kind of the aldehyde, okay, so ketone ester kind of nitrate, okay, so we can stand kind of strong base conditions, okay, give you kind of the eventually the kind of alkylation product, okay. Right. Here are some kind of example, okay. So here, first one kind of we have ester, okay. So we use kind of RDA as base, okay. So that's kind of long carbon chain as kind of substrate, okay, and then put kind of here, okay, put on the alpha carbon, okay. So for the alkylation, okay. So the common mistakes kind of the first student put kind of the alkyl group on the wrong carbon, okay. So casing, okay, find the alpha carbon, okay, alpha carbon kind of the carbon next carbonyl carbon, okay. So you put alkyl group on here, okay. So don't put kind of carbonyl carbon, okay. So some people put kind of carbonyl carbon, okay. So that's the wrong, okay. Carbonyl carbon kind of won't give kind of you break up octets loop, okay, or kind of do some kind of acyl substitution reactions, okay. Right. And then second one kind of nitrate compound that kind of the substrate, okay, do the kind of reactions, okay. So and then again find alpha carbon, okay, alpha carbon kind of the carbon next kind of nitrate group, okay, and then you do alkylation, okay. You can put kind of very kind of complicated kind of alkyl group on kind of alpha carbon, okay. So after that you found alpha carbon and then find kind of electrophilic carbon from kind of substrate, okay, and then you build bond between these two, okay. So you become the product, okay. Right, and the last one kind of also ester, okay, ester kind of this time case so because for this ester has the 2 alpha carbon, okay. So in this case, if you like, you can control add the 2 different kind of alkyl group on the alpha carbon, okay. So we just kind of apply kind of the 1 equivalent base, okay. So RDA in this case, okay, and then you deploy only 1 alpha carbon, okay, alpha hydrogen, okay. And then you put 1 alkyl group on, and then you use excess of kind of basically deploy the second kind of alpha hydrogen, okay, and you can put second alkyl group on, okay. So that's actually kind of pretty kind of cool method kind of you make here the multi alkylation kind of product. Okay. Right. So that's here one way to do kind of alkylation, okay. But here this way kind of you have to use kind of strong base, okay. So quite often you generate kind of a lot of byproduct, okay. So and some kind of region done like this way, like I already had, okay. So the more common to do kind of alkylation we use kind of the beta decarbonyl compound, okay. So beta decarbonyl compound, okay, we learned it before, okay. So so that kind of 2 carbonyl group, okay. So surrounded by kind of surrounded kind of alpha carbon surrounded by kind of 2 carbonyl group, okay. Because kind of the inductive factor and also kind of the resonance effect, okay. So make the center alpha hydrogen kind of more acidic, okay. So pK 9 to 10, okay, 9 to 11, okay. So much more kind of than kind of regular ester ketone or kind of the nitric compound, okay. So in this case, even you don't need to use strong base, okay. So the some kind of base like a sodium ethoxide enough to depronate kind of the alpha hydrogens, okay, and then you just kind of the Enolate, okay, and then go ahead to kind of all kinds of reactions, okay, all right. And here we will learn 2 the beta dicarbonyl compound, okay. One's called kind of the acetoacetic ester, okay. So So for this guy structure, so something like this, okay. All right. So acetyl, okay, so refers to this part, okay. That's acetyl group, okay. Acetic ester, okay, refers to this part, okay. So that's acetic ester, okay. So we have 2 parts, okay. Acetyl acetic ester, okay. All right. Clearly, okay, see kind of see the we can call kind of the beta carbonyl kind of the ester, okay. So the center kind of the alpha hydrogen has kind of the pretty acidic, okay. And this guy kind of pretty useful to synthesis kind of we call it the methyl ketone, okay. Yeah. So that's here the acetyl acetic ester, okay. So as a group, okay. So here kind of replace R, okay. And then you deploy kind of with the sodium hydroxide, okay. And then the just here you can do the alkylation, okay, and then followed by kind of you can deploy the second kind of alpha hydrogens, okay, and then you can do kind of the second kind of the alkylations, okay. And for the general reaction for you use acetyl acetic ester, okay, so I just show you guys, okay, so so sodium ethoxide, okay, so keep in mind, okay, and then we just put any kind of alkylate, okay. So once reaction is done, okay, just put kind of R on kind of alpha carbon, okay. But if you like, okay, so you can add 2 R group on, okay, so it doesn't matter, okay, so it really depends on how do you control the region amount, okay. Either kind of mono alkylation or the dialkylation, both are fine, okay. Yeah. And actually, the most kind of the coolest thing kind of about this reaction kind of you can do the decarboxylation, okay. So after reactions, okay, so you do second step reaction, okay. You hydrolyze, okay, so write down here, okay. The ester, okay, into carboxylate, okay. Yeah. Sorry. Okay, so into carboxylate. So what's the reaction name for this reaction? Okay, acid hydrides on the basic condition. Anyone remember? We're just learning kind of chapter 19. Type in the chart window. Okay, so acid hydrolysis kind of under basic condition. No one remember? Yeah, that's right. Saponification. That's right. Okay. All right. So you have to remember it. Okay. So yeah, that's what we will test on Friday. Okay. All right. So the cool thing kind of after you hydrolyze kind of the acid carboxylate, and you protonated kind of with the protons. Okay, acid work up. Okay, and you heat it up. Okay, and the whole thing. Okay, so whole carboxylate group. Okay, okay, it's gone. Okay, and then eventually you generate some kind of we call the methyl ketone. Okay. Methyl ketone. Okay. So that's this second step we call kind of decarboxylation. Okay. So that's shown here, decarboxylation. Okay. And if you have kind of two alkyl group, okay, put on kind of alpha carbon. Okay. So eventually kind of you have kind of the branch kind of the methyl ketone. Okay. So two alkyl group still there. Okay. All right. So this reaction actually can note hard. Okay. So the reason for that kind of the alpha carbon, the carbonyl group on the kind of beta carbon. Okay. So that's contain kind of this intermediate. Okay. So when you heat it up, okay. So this is carboxylic group. Okay. And then shift the electron 3 times. Okay. So you turn kind of carbon dioxide. Okay. And then with kind of enol. Okay. Enol quickly totalize into kind of ketone. Okay. The kind of final ketone. Okay. So that's here. Okay. So this reaction sequence, okay, eventually kind of you start with kind of acetyl acetic ester, okay, eventually generate kind of the methyl ketone, okay. So so that's one of the good way to prepare kind of the methyl ketone from kind of acetyl acetic ester, okay, because you can put kind of different alkyl group on here, okay. And I guess the no idea. What's no idea? Right. Okay, so I guess class we can stop here, okay, and so we continue this chapter on Friday, okay. All right, any questions? Okay. First, any question about the lecture, okay?